Multi-stage physicochemical method. The MPC method is represented by two companies: Ukrainian company Eastern Scientific and Technological Center and Prestel Energy, UK-based company. ESTC is a patent holder for the technology, manufacturer and supplier of chemicals, and performs well stimulation operations in Ukraine. Prestel is a partner and an official representative of ESTC and operates all over the world. The main benefits of MPC method are a combination of three types of impact: chemical treatment, mechanical impact, and thermal stimulation. By chemical treatment, we mean breaking down chemical bonding between rock and hydrocarbon and Poisson cleaning from mud and contamination with heavy oil components. Mechanical impact is creating of a new microfractures and channels and also enlarging of existing filtration channels and pores. Thermal treatment is a result of first two types of impact, where we launch short-term in situ hydrocracking pyrolysis of heavy hydrocarbon fractions. As a result, we get temporary temperature increase up to 500 degrees Celsius in the near wellbore zone. Some details about chemical impact. The treatment mainly is done by gases. Gases that are produced in the casing are directed inside the reservoir through perforation zones. Gas injection into the reservoir conducted by the law of optimization of flowing by a system of two gases. The flow speed of the gas system is directly proportional to the relationship between the mass of light gas, first produced as hydrogen, and the following heavy one, carbon and nitrogen oxides and other types of compounds. Using this phenomenon, we increase the flow speed in 7 times. The hot gas bubble is literally drawn in by the formation as soon as it approaches the perforation zone. Hydrogen plays the main role in the MPC stimulation. This component is a leader of our gas stream and the driver for chemical reaction in the reservoir. Hydrogen enters chemical reaction with oil components, starting the isomerization of molecule. Hydrogen reacts with paraffin, resin, asphaltene deposits, melting them and separating into smaller gasoline fractions. MPC technology is safe for health and environment. Worldwide track record proves no negative environmental effect, no damages or accidents. All chemicals are non-hazardous and eco-friendly. Prestel and ESTC has all required certificates for using and transporting chemicals to any part of the world. The main advantages of MPC technology are that standard equipment for workover can be used. For implementation of our technology, we can work with cold tubing unit or with workover rig, depending on the well completion. The materials that are to be pumped in the well are eco-friendly chemicals. All the operations for MPC implementation require from 2 to 3 days, including the well activation. And the last but not the least is that the MPC technology has long-lasting effect. The next slides demonstrate how MPC technology is going to be used on the standard vertical oil well. On the surface, from the left side, you can see the equipment that will be used for the job, and from the right side, you can see MPC chemicals A, B, and C. The first step is pumping the chemical A inside the well. Tubing show must be placed on the very bottom of the well. Chemical A is pumped inside the tubing through pumping unit. Chemical A has density 1.3 grams per cubic centimeter, and it is heavier than brine, and by forces of gravity it spots on the bottom of the well with a layer. The next step, we pump chemical B. Chemical B has density 1.6 grams per cubic centimeter, and it is heavier than brine and chemical A as well. So when chemical B gets out from tubing, it is directed to the chemical A. When chemical A and B are mixed, the first stage of our reaction starts. Mixture of two chemicals leads to the launching of exothermal reaction in the well bottom hole zone. This reaction increases temperature in the casing up to 200 degrees Celsius, 250 degrees Celsius. During this reaction, huge amount of gas will be generated. From 1 liter of A and B mixture, we get from 2 to 5 cubic meters of hot active gas. The first and the main gas of this reaction is atomic hydrogen. A and B fluids react between each other and generate gas. This gas is filtered inside the reservoir. When generated gas starts its movement through the formation, cleaning existing pores and channels, the reaction breaks down chemical bondings between heavy molecules of oil and rock. The contaminating and blocking materials will be melted and dissolved during chemical reaction in the reservoir. This impact reduces skin effect. Atomic hydrogen enters into the reaction with heavy oil components, launching in situ hydrocracking pyrolysis. This reaction leads to local temperature increase in the reaction zone up to 500 degrees Celsius. Such temperature increase improves oil mobility. Atomic hydrogen can penetrate into the closed pore space and make them open due to recombination from atom to molecule inside the pore. It means that with this impact, the recovery rate can be improved. The reaction does a multifunctional impact on the formation and fluid. The generated gas will saturate hydrocarbons, improving their mobility, and new microfracture network will be created due to impact of hydrogen and high temperature in the reaction zone. As it was mentioned before, the temperature will be increased up to 500 degrees Celsius locally in the formation. Such difference between our reaction temperature and formation temperature will create a microfractures in the zone of reaction. Those microfractures networks will significantly improve permeability. The reaction between A and B chemicals lasts from 12 to 24 hours inside the casing. The next day, the last stage of our reaction is pumping of chemical C. Chemical C consists of hydrochloric acid and MPC additives. When chemical C reaches the products of reaction between A and B chemicals, the process of neutralization and acid vaporization starts. On this stage, we combine conventional acid treatment with hot active acid gas treatment. On this stage, we treat formation with fluid and gases. Chemical C reacts with A and B products of reaction and launches vaporization of nitric acid, hydrochloric acid, and acetic acid. All these gases will be penetrated inside the formation. This stage allows us to maintain the reservoir temperature for a longer period of time and make a positive impact of acid on the formation. Chemical C component pumping is optional. In case hydrochloric acid is not compatible with the reservoir or fluid, this component can be removed from the treatment list. On this slide, you can see our main customers and our track record map. Now, we would like to draw your attention to the recent MPC successful implementation in the Middle East region. 2 wells were treated in 2021 and 2022. Well A, production before treatment, was 216 barrels of oil per day in 2021. Production after MPC implementation reached 300 barrels of oil per day. On well B, production before treatment was 191 barrels of oil per day, and production after MPC treatment reached 401 barrels of oil per day. Sustainability of MPC effect on the first well is more than 2 years, and on the second well is around 9 months already. Thank you for your attention.